Okay, the third section in chapter 3 of linear equations and graphing lines. And as we graph lines, we talked about graphing by the plotting points and talked about the intercepts. Now we're going to talk about the slope of a line. And the slope of a line is basically the steepness of a line. It's like how steep is the line rising, or how steep. It could be how steep is the line rising, and that would be a positive slope, or it may ask you how steep is the line falling, and then that's going to be a negative slope. So it's the steepness of the line, and the slope is measured, is a ratio, and that ratio is measured by the change in y divided by the change in x. This delta means change. And in mathematics, or in this section, we use to indicate the variable m for the slope. So if we had for example, if we had a point here, we don't know what the point is, it's just that point on the line. And say we have another point on the line, we'll put the point here. So you have 2 points on the line. We don't know what those points are, but we'll say that this point right here is maybe x sub 2, y sub 2. And maybe this point is x sub 1, y sub 1. And these subscripts just means that it's the first point. And, this could be the first point and this could be the second one. I just labeled it the first and second point. So if you start talking about the steepness of the line or the change in y, so when you look at the change in your y variable divided by your change in your x variable, if we kind of look at how the y variable changed, so from here to here is your change in your y, and then from this point to this point is your change in your x. And how do we get that? The change in the y divided by the change in the x. Again, the ratio, the slope is measured in terms of a ratio. So the slope is a ratio of how the x value changes and how the y value changes. So how do we get them to change, or how do we find the change? Well, you can subtract. So if you say, for example, you have the variable m, you're looking for the change. If you look for the change in your y variables, you're going to just subtract y sub 2 minus y sub 1. And if you think about the change in your x values, you subtract the 2. So you have x sub 2 minus x sub 1. This is a formula you should know. Write it down and put it in your notes. Sometimes you may be familiar with it. Sometimes students will refer to the change in your y variable because it goes up and down, is your rise if you're plotting points, and then the run is your horizontal x-axis, so the rise of the run. So you may have heard that when you're dealing about the slope of a line. But more importantly, you want to make sure that you make this formula in your notes. You will need it as we continue to talk about the slope of a line. So remember, the slope of a line is the steepness of the line. Okay, in 3.3, we're also going to be talking about the equation of a line. And we already know that the standard form of an equation of a line is ax plus by equals c. And I want you to make sure that you understand that that's the standard form of a line. And we'll be talking about the standard form and the slope-intercept form. The slope-intercept form of a line, what we're going to be working with mostly in this chapter or in this section. This is still in both are equations of a line. Now, I want you to make sure both are equations of a line. This is the standard form, and this is the slope-intercept form. And one reason or how you can remember this is the slope-intercept form is that the slope-intercept, you can just look at this equation of a line and determine the slope and the intercept. Remember, the variable m stands for the slope, and variable b is the y-intercept. And remember, the y-intercept is any point 0 where you have a point y at, because the y-intercept is where x equals 0. So that's the second thing that we're going to be learning in section 3.3. We have the slope and the equation of a line, but I want to re-emphasize now, when we're dealing with these slopes, we want to make sure that we understand the slope-intercept form. Both of these are equations of a line. This is a standard form. This is a slope-intercept form. Write them down. You want to make sure that you understand both. The third thing that we're going to be learning in 3.3, the slope of the line, is we're going to be looking at the characteristics of parallel and perpendicular lines. And those characteristics will be around the slope. So we'll be looking at the slope of parallel and perpendicular lines. So let me make sure that you understand the difference, or at least know the difference between parallel and perpendicular lines and what their slope looks like. Again, you have the Cartesian plane. We still have our x and y axis. So our slope, or our parallel lines. So let's look at parallel lines. Parallel lines are like this. Let me change the color here just for. So this is a parallel line, or these are parallel lines right beside each other. So the characteristic that you want to know about parallel lines is that they have the same slope. So maybe we'll call this the slope of line 1 and the slope of line 2. Parallel lines have the same slope. So that means that the slope of line 1 is going to equal the slope of line 2. So that's a characteristic that you want to know, that the slope of parallel lines are equal slope. They have the same slope. When you have perpendicular lines are lines that form a 90-degree angle. We'll call this slope 1 and slope 2. And when you multiply, lines are perpendicular when you multiply their slopes. When you multiply the slope of line 1 and the slope of line 2, it equals -1, or the negative reciprocal of each other. So this is a characteristic that we're learning: parallel and perpendicular lines. Parallel lines have the same slope, and perpendicular lines, when you multiply their slopes together, you equal -1. So in 3.3, there's three objective, or three dynamics, or three things we'll be learning about, and the slope of the line. And that's when we'll be learning about the steepness of a line. And in order to get that steepness of a line, we have to make sure we understand the slope. And we know the slope formula is y equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And this is just a formula to find the slope of a line when we have 2 points. And then we have the equation of a line. And primarily in this section, we're going to be looking at the slope-intercept form of a line. And that's y equals mx plus b. And again, we call it the slope-intercept form because you can just look at it and see the slope, and you can look here and see the y-intercept. However, you must be solving for y. So you need the y over here equals mx plus b, the slope-intercept form. But I also want to remind you of the standard form of an equation of a line. I don't want you to forget that. But as we look at the slope, we'll primarily be looking at the slope-intercept form. And when we look at parallel and perpendicular lines, again, we're looking at the slope of parallel lines. And you want to know that the slope of parallel lines have the same slope, and the slope of perpendicular lines is a negative reciprocal. So when you multiply them together, the slope of the first line and the slope of the second line, it equals -1. And these subscripts just means that's the slope of the first line, slope of the second line. And the same thing here. These are like X and Y points, and X of 1 and Y to 1. This is the first point, and X of 2 and Y of 2 is the second point. And it's just to distinguish the point. So these are the 3 items that I will go through the workbook and give you some examples. So going to the workbook now. Okay, so this is from the workbook, a few problems from the workbook. In the beginning, we talked a little bit about this, the slope and the steepness of a line. You can pause the video to look at that again. And then there's something here about positive and negative numbers. When it rises from left to right, it's a positive slope. And if it's slant downwards or fall is a negative slope. And you want to kind of recognize those characteristics. And it's mentioned here the slope of horizontal and vertical lines. So you want to make sure that you kind of note this. Horizontal lines have the slope of 0. Horizontal lines have the slope of 0, and all vertical lines that are in the form x equals a constant, those slopes are undefined. So you want to make sure you note that. So let's look at these examples here. And this is just an exercise to show you or to demonstrate the lines, whether they're positive, negative, 0, or undefined. So you have 4 categories here. You have lines over here. So identify A, B, C, D in the figure and determine, for each line, determine which of the following is true. So we look at the positive slope. The slope is positive. So remember, positive slope is the line that's rising to the right. That's rising to the right. So if we look at these slopes, line B is a positive slope. So line B is the positive slope. The negative slope is going in the other direction. So line A is a negative slope and E is a negative slope because both of them are rising to the left. So lines A and E are negative slopes. So you have lines A and E. So slope of 0. So when you look at slope of 0 and undefined, you're looking at 0 and undefined. If you look at 0, it's when y equals a constant. And y equals a constant is a horizontal line. So that means that all of our horizontal lines are 0. And I think this is line A here, this blue line. Okay, wait a minute. And so I got the negative slope of A. So maybe this is line D. I'm looking at this. Yeah, maybe this is line D. So maybe that's the negative slopes are D and E and not A and E. I think this is, yeah, this is E and D. So we're going to say this is E and D. So this purple line is line D. This A is the green, is the blue line. Looking at, so this A is a blue line here. So this is a horizontal line, and that slope is going to be 0. So all of our slopes, our horizontal line is 0. And then our vertical lines are undefined because undefined where x equals a constant. So our vertical line is C, and this looks like C. A, B, C, D, E. Did we get them all? Yeah. Okay. So this is just an exercise. So when you look at the slope, when we start solving it and you have a negative slope, you know it should be rising to the left. If it's a positive slope, it's rising to the right. If the slope is 0, that means that it's a horizontal line. And if the slope is undefined, that means it's a vertical line. So just some more characteristics that you want to be aware of. So let's look at the first example here. It says, find the slope of a line, the slope M, that goes through these points. So whenever you have to find the slope of a line, it is giving you 2 points, automatically you need the formula. The slope of a line is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. You need to know the slope. Okay, so when we know the slope, all you have to do is just plug in the numbers. And one of the things that I try to get students to do is that you should probably label these points so you just won't, get them confused. And it doesn't matter. We'll just say that this is x sub 1, y sub 1, just because it's the first point there. This is a subscript. So this is x sub 1, y sub 1. And then this will be x sub 2, making sure that this is a subscript y sub 1. So I don't have them right up under each other, but I hope you get to see what I'm trying to do here. And this is a subscript. X sub 1, comma, y sub 1. And this is not, both of them can't be y. So, both of them can't represent the same point. So that's x sub 1, y sub 1. This right here is x sub 2, y sub 2. So this is x and this is y. All right, so we're just going to put it in the formula. So you have y sub 2. Y sub 2 is -1. So the slope here equals -1 minus, because you have a minus sign in the formula. And so y sub 1 is -1. So you want to be careful here because there's a negative in this formula and y sub 1 is -1. So that's minus a -1. The denominator, again, the ratio, slope is a ratio. So you have x sub 2, which is 1, minus x sub 1, which is 3. So in our numerator, we have 1 plus 1. 1 minus 3 is -2. So the slope here is 2 over -2. So the slope here is -1. So that's how you find the slope. You want to make sure that you know the formula and just label the points just so you can substitute correctly and then solve algebraically. Find the slope of a line that's going through 2 points. Okay, over here, find the slope of a line that goes through the points, and it says draw the graph. So we're going to find the slope the same way, but we're just going to plot the points over here. Okay, so, or better still, it says to draw the graph, we can plot the points first. This is 1, 4, go over 1 and then up 4 because the points are not going to change. So that's 1, 4. And then this is 3, 4. So if you go to the right 3 and go up 4, check it out. So we have plotted this point. And can you see that this is a horizontal line? So we already know what the slope is. The slope of a horizontal line is 0. So when we graph these points, or when we go through the slope, we should make sure it should be 0 for confirmation. So we're drawing the graph, and now we're going to do the algebra of it for confirmation. Again, this is going to be x sub 1, y sub 1, just to label the points. This will be x sub 2, y sub 2. So I'm trying to get the points to be right up under here, but my pen is too large. So, this is x sub 1. Oh, okay, that's not going to work. Or maybe I need to reduce the size of the pen. Let's see. I don't want to be too long. I got it real thin. Let's see what this is. Okay, so this is x sub 1, y sub 1. This point is x sub 2, y sub 2. And again, the subscript just means that that's the first point and the second point. So let's do the formula. You know the formula of a slope is y sub 2 minus y sub 1. And if you don't know it, this is like one of our core learning principles of the class. So you want to make sure that you know the slope. And if we substitute, the slope is y sub 2 is 4 minus y sub 1 is 1 over x sub 2 is 3 minus x sub 1 is 1. Okay, wait a minute. So I'm not doing this right. Hold on. Y sub 2 is 4. Y sub 1. Y sub 1, check it out. Y sub 1 is 4. So you want to be careful. All right, I'm going, y sub 1 is 4. And then x sub 2 is 3. That's why you label them and be careful. Minus x sub 1, which is 1. So the solution here, 4 minus 4 is 0 over 2, which equals 0. So the slope here is 0, and it's confirmed by our horizontal line. All right, let's look at the second one here. Again, so let's just plot the points first so we can kind of know what the slope should be like. So they should be the same. So let's plot these points. -3, 2. Again, starting at the origin, you're going to go over -3 and then 2. So this is right here. And then -5, -3. -5, -3. So go over to the left, 1, 2, 3, 4, 5, and then go down 1, 2, 3. So this point is right here. So when we, so this is what the graph looks like. So when we graph this, that means that we should have a positive slope because this is rising to the right. We should have a positive slope. So let's see if we can do the algebra and verify it. Okay, so this is, I'm gonna try to write up here. This is x sub 1, y sub 1. This is x sub 2, y sub 2. Put a comma between them. All right, and then you have a slope. The slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. These are subscripts here. I want to make sure that they're small enough to be subscripts. Okay, so y sub 2 is -3 minus, so minus goes in the formula, y sub 1 is 2 divided by x sub 2 is -5 minus x sub 1 is -3. So again, I want to emphasize that there's negative sign is in the formula, and this number is also -3. So this is -5 minus 3. So if we simplify that, we'll have -5 divided by -5 plus 3, because these two negative numbers are positive. So this becomes -5 divided by -2. And you have two negative numbers. So the two negative numbers makes that reduce to 5/2. Okay, so this is the slope 5/2. So let me just demonstrate while I'm here. If you look at the difference between this point and this point, the y changes. So again, now 5/2, the slope equal 5/2. This is the change in y divided by the change in x, because the slope is a ratio. These are delta symbols here. Delta means change in mathematics. So this is the change in y divided by the change in x. So if we look at these points, if these are the y values, you go up 1, 2, 3, 4, 5. This is the change in y. You're going over 1, 2. It's not straight on the line. But anyway, so that gives you the an illustration that this slope is correct. And it doesn't matter, even if you take two other points on the line, you're still going to have the same slope. Okay, the equation of a line in two variables. The equation of a line, linear equation can be written in the standard form and the slope-intercept form, and that's what we have here. So you want to make sure that, and it tells you the y equals mx plus b is m is the slope and y is the b is the y-intercept. So let's look at the directions here. It says find the slope of a line given the equations below. Find the slope of a line given the equations below. Really, and this is not, I hope that if you can handle the algebra of it, these should be pretty standard, but you don't want to get too confused, because remember, if it's in this y equals mx plus b form, you can just look at it and find the slope. So if we look at number one, this is y equals 4x minus 1. All right. It says find the slope. Y equals mx plus b. So when it's already in that form, remember, we can just look at it and we know that the slope here equals 4 because it's already in the y equals mx plus b form. Let's look at number 3. All right, find the slope here. So don't automatically just look at this coefficient 2 and say that this is a slope, because you have to make sure you can take this equation and solve for y. So hopefully algebraically you can take 2x equals y plus 1 and solve for y. So I'm going to subtract 1 from both sides. So y is going to equal 2x minus 1. And I'm just going to write it in the reverse order. So y equals 2x minus 1. Okay, so in this case, yes, the coefficient before the x is the slope. All right, so the slope here equals 2 because this is y equals mx plus b. The coefficient here is your slope. -1 is the y-intercept. If we look at 5 again now, don't always look at the coefficient before the x to be the slope. Let's solve for y here. So we take this equation 5x plus 2y equals 2. We're solving for y. So we're subtracting 5x from both sides. So this becomes 2y equals -5x plus 2. And then we're going to divide everything by 2. So we have y equals -5 halves x plus 1. So here the slope is -5 halves. And remember, the slope is only the number. It's not -5 half x. It's only the number. You know that this is a negative slope. So if we were to graph this, I don't know what, if we were to graph this, I'm just going to squeeze it in here. Well, we know that the y-intercept is going to be +1. So we know that it's going to cross the line right here where x equals 1. And then this is y-intercept. So if we go down 1, 2, 3, 4, 5, and then maybe to the left 2, the line is going to look something like that. And we'll get to that. I just want to throw that little explanation in. This is your x and y axis. But the objective was to find the slope of the line. And to find the slope of the line, all we did was put it in this y equals mx plus b form. So we can just look at the coefficient of the coefficient of x and find the slope. It's the coefficient. So the slope is not -5 halves. It's only the coefficient negative. This is not -5 halves x. Is only the coefficient -5 halves. So this is kind of what I talked about in the beginning, that parallel lines have the same slope, and perpendicular lines, when you multiply the slopes together, you equal -1, or they're the negative reciprocal of each other. So you can take another look at that, pause if you like. And again, now these are from the workbook, so you can just follow along with the examples here. All right. Okay, as I look at these, I look here, I think that this should have an X there, but I'm not going to put an X there because if you were working on it, you wouldn't know that. And since I'm lecturing, I'm just going to go and keep it like that, and we'll find the solution. Direction says, determine whether the pair of lines are parallel, perpendicular, or neither. We know parallel lines have the same slope. Perpendicular lines, when you multiply the slopes together, you get -1, and then neither is when they don't have that relationship. All right, so let's look at here. So really, in order to determine whether the lines are parallel, so in order to determine whether these lines are parallel, perpendicular, neither, basically you just have to look at the slope. So in order to look at the slope, all you have to do is solve for y. We take the first equation, 2y equals 4x plus 7. Again, we're looking for the slope. Solving for y, we're dividing everything by 2. So here we have y equals 2x plus 7 halves. So the slope, let's put like here. The slope of line 1 is 2. And since we're here, if I was asking you, I'm not, but if I was asking you, you could say that the y-intercept of 7 halves. If we look at the second equation, 4y plus 2x equals 0, and 4y equals 2x, and y equals 1/2 x, and the slope of line 2 is 1/2. So let's check our math here. 2y dividing everything by 2. 2x minus, okay, so the slope here is 2. 4y plus 2x equals 0. Okay, so make sure we subtract here. Just checking my algebra here. This should be -2x, right? Should bring it to the other side. Divided by 4. -2 divided by 4 is 1/2. So this should be -1/2. So we know that they're not parallel lines because the slopes are not the same. But if we multiply 2, which is the slope of 1, times -1/2, that equals -2/2, which equals -1. And when you multiply slope 1 times slope 2, and it equals 1, that means that they are perpendicular. So determine whether the lines are parallel, perpendicular, neither. So the lines here for number 4 are perpendicular. Perpendicular. Okay, so again now, in order to determine whether lines are parallel, perpendicular, or neither, you're looking at the slope. The slope of the first line is 2. The slope of the second line is -1/2. You multiply them together. Multiply the two slopes together, you equal -1. And when you multiply them together, these lines are perpendicular. Okay, let's look at number 6. Directions are the same. Determine whether the lines are parallel, perpendicular, or neither. Again, you're just looking at the slope. I'm going to use the space here. This is 7y plus 2x equals 4. Solving for y, because we're trying to get it in this y equals mx plus b form. so we can just look at it and identify the slope. So we're subtracting 2x from both sides. We have 7y equals negative 2x plus 4. We're dividing each term by 7. So we have y equals negative 2 over 7x plus 4 sevenths. So the slope of this line, the slope of line 1 is negative 2 sevenths. Look at the slope of line 2. We have 7y plus 1, 7y equals 1 plus 2x. Again, solving for y. We're dividing everything by 7. And we can go and use the commutative property and change these around, right? Hope you're comfortable with that. So y equals negative 2 over 7x plus 1/7. All right, so the slope here is negative 2, 7, and the slope here of line 2 is negative 2, 7. So if we were to graph this right here, because they have the same slope, then that means that these are parallel lines. P-A-R-A. These are parallel lines. So if we look at number 7, again, now we're solving for y, so we can look at it and find the slope. So we have 6y minus 5 equals negative 9x. We're adding 5 to both sides. So we have 6y equals negative 9x plus 5, dividing everything by 6. So y equals, let's go and reduce this to the lowest term, dividing both of them by 3. So that equals negative 3 over 2x plus 5, 6. So the slope of this line, slope of line 1 is negative 3 halves. Let's look at here. I think this should be an X there, but I'm not going to just put an X there, because if you were doing the worksheet on your own, then you wouldn't put an X there. But this is, let's just say y equals negative 3 halves plus 2 over 2, which is fine. So y equals negative 1 half. And you know y equals negative 1 half. The slope of a horizontal line is 0. Okay, so the slope of this horizontal line is 0 because there's no x, and the slope here is negative 3 halves. So for here, it's neither. All right, so again, in order to determine whether lines are parallel, perpendicular, or neither, you have to find the slope. The same slopes are parallel line. When you multiply the slopes together, they equal negative 1, means that they are the reciprocal. So this section 3.3, the slope of a line, we talked about the steepness of a line. And when you find, that's what the slope is how steep is the line. It's a ratio between the change in your y divided by your change in your x. And you need to make sure that you know this formula for the slope of a line. We talked about the equation of a line and how you find the slope. And primarily, if you put it in this y equals mx plus b form, the slope-intercept form, you should be able to look at it very nicely to find the slope. And then the last thing that we learned in this section was parallel and perpendicular lines. And more importantly, or characteristically, we were looking at the slope of parallel lines, and the slope of parallel lines are the same. And the slope of perpendicular lines, when you multiply them together, it equals negative 1. So that's 3.3 slope of the line.